Alright, so MSM 131, tutorial sheet 2. Let's just do a continuation on that. Okay. Okay, so question 7, starting with question 7. Question 7, you've been given a question and you've been asked to say, state whether the following function is actually, the following relation is a function. Okay, so we have y is equals to 4x plus 1. Now, ladies and gentlemen, one of the things that we need to note is not all relations are actually functions. Okay, so we're saying not all relations are functions. Not all relations are functions. So when does a relation qualify to be a function? A relation qualifies to be a function if number one is a one-to-one, or it's actually a many-to-one, but not a one-to-many. Okay, so we have one-to-one functions and we have many-to-one functions, right? So, but we're saying that, for instance, this particular part of the relation, so it says from R to R. Okay, so the domain is R and the range is R. So you are mapping the values from the real line onto other values from the same real line. Okay, so we want to know, is this y is equals to 4x plus 1 a relation, and this relation a function? So to determine whether this relation is a function, we just have to check, is it a one-to-one? Okay, so is it a one-to-one? So how do you show if the relation is a one-to-one, if a relation is a function? So to check if this relation is a function, we're going to simply say or ask ourselves, so every value we put here as x, will the answer be unique? Okay, for every value of x that we have, will the answer be unique? The answer is yes. Okay, so meaning this one is actually one-to-one. So let's say this is equals to f of a and this is equals to f of b. So we want to determine whether this is actually a one-to-one function. Okay, so to determine whether this is one-to-one, what we're going to do is I'm going to replace where this x with a, so we have 4a plus 1 is equals to 4b plus 1. Okay, so 4a plus 1 is equals to 4b plus 1. Then we have 4a is equals to 4b plus 1 minus 1, so the ones will cancel. Then we have 4a is equals to 4b over 4 over 4, so we have a is equals to b. Okay, so meaning that this is actually a one-to-one relation. Okay, so since it's a one-to-one relation, this is actually a function. Alright, so I simply have to check for every value I find or I pick from R and replace with x, will the answer be always unique? If the answer is yes, then you know this is a one-to-one function. Okay, so that's how you determine whether it's one-to-one. So we are talking about if this particular relation is a function. Okay, so for it to be a function, it has to be either one-to-one or many-to-one relation. So to check if it's a one-to-one, what did I do? I simply placed a where there's x here, and I equated this to b. If a ends up being equals to b, then we know that this is actually a one-to-one, so this relation is a function. Remember, one-to-one-to-one or one-to-one relations are actually functions. Okay? So yes, this particular relation is a function. Let's consider a different type. What of x is equals to y squared plus 1? So is this one-to-one? So we're going to say y squared is equals to x minus 1, right? Then take the root. Both sides, we have made y the subject of the formula, so we are basically looking at root of x minus 1. So the question is root of x minus 1 a relation? This relation, is it a function? So again, we are asking ourselves, for every value of x you pick in here, is this going to give you a unique value? The answer is yes, okay, because for any number you pick here, there's no number that will give you the same answer. So this is also a function. So we can check. We're going to say f of a should be equals to f of what? B, right? So I'm going to replace a where there's x, so we have root of a minus 1 is equals to root of root of b minus 1. Then I'll square both sides, because I want to get rid of the root. Then I have a minus 1 is equals to b minus 1. Alright, the 1 will go the other side, so I have a is equals to b minus 1 plus 1. So this and this will cancel, so the answer is a is equals to b. Right? So if you check this answer, which is a is equals to b, so I'm saying a is equals to b, right? If you check this answer, a is equals to b, this simply shows us that this is a one-to-one function, right? So since it's one-to-one, and we already said this relation, a function is a one-to-one relation, so meaning this particular relation which you have, x is equals to x, y squared plus 1 is also a function. Okay, so that's how you determine. You simply check for every value that I pick in this real number here. If I pick any value here and replace where there's x, will the answer be unique? If the answer is going to be unique, then you say yes, it is a function. Okay. Then if we ask you to prove whether it's a one-to-one function, what do? You're going to say f of a should be equals to f of b. If the answer ends up being a is equals to b, then that particular function is one-to-one. Okay, because remember, a function may not always be one-to-one, it can also be many-to-one. Alright? So, an example of a many-to-one function, assuming that f of x is given as x squared plus 1. Okay? So, if you look at this x squared plus 1, this is actually a one-to-one function. Because, this is a many-to-one function. Because if you pick, let's say, let me just pick a small domain, -2, +2, 1, and -1. Okay? So, let's assume this is your domain. What is your range? Our range is going to be, I'm going to replace -2, so we have f of -2, which is going to be -2 squared plus 1, which is, -2 squared is 4 plus 1, 5. Then we have f of 2, I'm just replacing the values from the domain into the function, okay? So f of 2 is 2 squared plus 1, which is still 5. Then I have f of 1, I've picked this one, I've put where there's x in f, so we have 1 squared plus 1, so we have 1 plus 1, so which is 2, alright? Then we have f of 2, f of -1. F of -1 is simply -1 squared plus 1, which is again 2, okay? So if I'm going to draw, so what is our range? So our range, therefore, simply has the values 5 and 2. Okay, so that is our range. If you were to map this, you notice that -2 and 2 both are maps to 5, and 1 and -1 are both maps to 2. But this is a function. This is actually an even function. Okay, so that is a many-to-one. Why? Because you've got more than one value, -2 and 2, going to one value in the range, which is in this case 5, and for 1 and -1 both going to 2. Okay, so that's an example of a many-to-one function. So I'm saying a function can be one-to-one or many-to-one, right? So in conclusion, we're saying we have different relations. We have a one-to-one relation, we have a many-to-one relation, we have a one-to-many relation. But not all relations are functions. Which relations are functions? A relation is qualified to be a function if and only if it's a one-to-one relation or a many-to-one relation. Okay? Not a many-to-many, not a one-to-many. Okay? let's look at a different question. Y is greater than x plus 3. We are still on question 7. Is this relation a function? Okay. This looks like an inequality. Of course, it is an inequality. So the question is that, does this have a unique solution? That's how we are going to know whether this thing is actually, we know that this thing is not going to be a one-to-one, okay? Because of, it's an equality, that's no equal sign, okay? So we're saying, for us to determine whether this particular relation is a function, we simply have to check, are the solutions unique? So meaning that we will have a solution that is unique from this, but is that true? Okay, so what are we going to check in this case? For every value of y you have, will the solution be unique? So for instance, let's say, remember I'm dealing with R to R, huh? So let's say for x being equals to 5, then what will this be? We'll have y is greater than 5 plus 3, so y is greater than what? 8. Let's pick another value, maybe 2. So for x being equal to 2, if I put 2, what will we have? We have y is greater than 2, I'm replacing here, plus 3, so y is greater than 5. Okay? Then let's pick maybe a negative number, negative 17. Okay, so we have for x being equal to negative 17, what we have? Y is greater than negative 17 plus 3. Y is greater than negative 17 plus 3 is negative 14. Okay, so y is greater than negative 14. Now, if you look at that, are these solutions unique? Are these solutions unique? So if you can write this, what does this mean? This is the same as 8 to infinity. So remember, because it's strictly greater than, so it's open up to infinity. Then we have this being, we have y is greater than 5, so meaning we have open at 5 to infinity. Then if you look at this, you have the last one as negative 14 up to infinity. Alright, so are these solutions unique? Okay, you notice that as you move from negative 14 to infinity, you meet 8 to infinity. So this is not a one-to-one. I mean, this is not a function. Okay, so we're saying this relation is not what? Because you've got this particular solution here is still mapped to this. Okay, so it's like you're now moving from many to one. That actually gives us a better conclusion. Okay, you can see that this one meets this one somehow, this one meets that somehow. Okay, so because of that sort of nature, this one has a unique solution. So for each particular value that you pick in the domain, okay, so our domain is R, the question is the answer still going to be unique? That's what we're looking at, okay? So we're saying, no, the answer will not be unique. That is in relation to one-to-one, okay? But for it to be qualified to be a function, it has to be either one-to-one or many-to-one. So can this qualify to be a many-to-one? If you consider that this is in here, and this is in this is also in here, can we actually conclude to say this is actually a many-to-one relation? Yes. Okay, so since it's a many-to-one relation, this one is also a function. End of that. But it's not one-to-one. Okay, it may be a relation, but it may be a function, but it's not a one-to-one function. That is a many-to-one function. Alright, so let's quickly do a set of unique questions. So I've been given f of x is equals to x squared, okay, and g of x is equals to 1 over 2x plus 1. So the question here now is find the inverse of that, okay. So what is f inverse of x? F inverse of x, we say y is equals to x squared, then we make x the subject of the formula, so we have x is equals to root of what? Y. So this is f inverse, okay. Then from here we are going to say what is f inverse of x. So where there's y, we replace with x, so it ends up being root of x. So that's the inverse. What is g inverse of x? So g inverse of x from this, we have 1 over 2x plus 1 as g inverse, so we have 1 as g of x. So y is equals to 1 over 2x plus 1. 1 over 2x is equals to y minus 1. Then I want to get rid of the 2, so I multiply throughout by 2. Then we have x is equals to 2y minus 2. Okay? If I multiply throughout by, so this one here is what we're calling g inverse. Okay? So g inverse of x is therefore equals to 2x minus 2. What was f inverse? So we said f of x is equals to x squared, so y is equals to x squared, root x is equals to root of y. This is what I'm calling f inverse. Then f inverse of x is therefore equals to root of x. Okay. So that's the inverse. Question 9. Okay, so we've been taught to sketch this on the same diagram. So we've been taught to sketch on the same diagram. How do we sketch? We've been taught to sketch f and g on the same diagram. So sketching this, we know that f of x is this, it passes through 0. Okay, so this is f of x, standard. Then we are looking for g of x. What is g of x? It's a straight line. So since g of x is given as 1 over 2x plus 1, we want to know what is the y-intercept. So y-intercept x is 0, so that is just at 1. So let's say this is my 1. Then also I want to know what is the x-intercept. So x-intercept, okay, y is 0. So meaning that we are going to say 1 over 2x plus 1 is equals to 0. Then 1 over 2x is equals to negative 1. Multiply throughout by 2 because I want to get rid of the 2 here. So we have x is equals to negative 2. Okay, so that's the x-intercept, negative 2. So passes through there, but it's a straight line. So cuts here, cuts there. Then this is 1, this is negative 2. Okay. Alright, so this line here, so the function here is f of x, and this straight line here which we have is g of x. Okay, so I've sketched that. question I've been given is, if f of x is equal to x squared minus 9, if f of x is equal to x squared minus 9, and g of x is equal to root of 9 minus x squared. Okay? So I've been asked to find f of g of x. Now, f of g of x simply means replace g of x where there's x in f. Replace g of x where there's x in f. So, x is here. What is g of x? That is g of x. So we have that. So I'm going to say g of x squared minus 9. But do you know what g of x is? Yes. It's root of 9 minus x squared. Then this and this will cancel. So we have 9 minus x squared minus 9, so the answer is just negative x squared. Okay? So what of if we were asked for g of f of x? So to find this, we're going to replace f of x where there's g. So g of f of x, this is equal to, so we're now replacing, so this is 9 minus f of x squared. F of x is x squared minus 9. Okay, which ends up being the root of 9 minus x squared. Then there's a squared here, of course. Alright, so it's inside. So now what we're going to do here is now, ladies and gentlemen, I can expand this. This is x to the power 4, okay, minus 18x squared plus 81, okay. 9 minus 81 is 72, so we have negative x to the power 4 plus 18x to the squared minus 72. Okay, so that's the final answer which we have. So we're saying I simply replaced f of x where there's g of x in that function. Then the rest was manipulation. Lastly, you've been given this as a piecewise function, okay? X squared minus 4 for x less than 2 and 5 for x greater than or equal to 2. So I'm saying x squared minus 4 for x less than 2, and we have 5 for x greater than or equal to 2. Okay? The first thing you've been asked to find is f of negative 1. So how do you solve such a question? To find f of negative 1, all you have to ask yourself, remember this is a piecewise function known also as a stepwise function. you simply consider the function based on the domain. So this function is always x squared minus 4 for any value less than 2, okay? For any value less than 2, the function f of x is this, okay? For any value greater or equal to 2, the function f of x will always be 5, right? So f of negative 1, is it greater than or is it less than 2? So negative 1 is actually less than 2. So meaning this is negative 1 squared minus 4, which is simply 1 minus 4. The answer is negative 3. Just that. Okay? Let's consider f of 1. Is 1 greater or less than? 1 is actually still less than 2. So the function is still 1 squared minus 4, which is 1 minus 4, which is 3. Negative 3. So in short, I'm saying, then what is f of 4? If you consider f of 4, what is 4? 4 is actually greater or equal to 2. So for anything greater or equal to 2, the answer is 5. Alright, so you consider the range for any value greater than or equal to 2, the answer will always be 5. So f of 4 is simply 5. If you are asked for f of 100, this is still 5, okay? As long as it's greater than or equal to 2, the answer will always be 5. This marks the end of our tutorial this afternoon. Have a blessed day, okay?